Alright, so sorry about the shortness on time because of that drill we did, but here's the completion of your notes. So we were doing this problem to find y, and y is on EF, and its corresponding side is AB. And then we picked another pair of corresponding sides, DE from the smaller quadrilateral, and DA from the bigger, which we know both lengths. And now we plug in what we know. Y over 5 is equal to 6 over 9. We cross multiply. So I'm going to do that here. 9y is equal to 30. And we'll divide by 9. Y is divide by 3, 10 thirds. You can also do the decimal. I'm not going to be too picky. 3.33. Just give me 2 decimal places, and that'd be great. And there we go. Okay, the next problem is an interesting one. Put a star next to it, okay? It's a specific problem that you'll see later, so make sure you can do this. So what we want is we have a poster, and it's from problem 4. I wrote the dimensions here. 6 inches high by 10 inches wide. We want to know what are the dimensions of the largest complete poster that will fill the space 3 feet high and 4 feet wide. So the idea is we're going to take this poster, we're going to blow it up, and we want to make it as big as we can to fit this space, this wall. Alright, so there's a couple steps. First, you got to make sure all your units are the same. Always convert big to small, so that means we're going to take our 3 feet high, and we're going to convert. 1 foot is 12 inches times 12, 36 feet, and that is the height. Take 24 times 12, and we have by 48 inches. Sorry, this is 36 inches. Sorry. 36 inches high by 48 inches wide. Step 2. So now that we're all in the same inches, now we need to find the fit. And to do this, we have to pick the smaller factor. So what's going to happen is we are going to compare the heights and going to compare the widths. So if I compare the heights first. The space is 36 inches high. And I want to fill in a 6-inch high poster. So by what factor could I blow up the poster? When you divide, factor of 6. And now I compare the widths. Again, I have a 48-inch space. I want to stick a poster in there that is 10 inches high, or 10 inches wide, sorry. This comes out to be 4.8. You must pick the smaller factor. This is the winner. So what this means is we are going to fit the width. The width wins. This is the fit. That means your width is going to be the entire width of 48 inches. But now we need to figure out, okay, then what's my corresponding height going to be? In step 3, find dimensions. So my width is going to be 48 inches. This is going to be one of my dimensions. The other one is going to come from the height. And what I have to do is I have to take my poster height, which is 6 inches, and times it by that scale factor of 4.8. And when I do 6 times 4.8, I get a number of 28.8 inches. And that is going to be the height. So this is the height. So your dimensions are, or your biggest fit, your biggest poster is 28.8 inches by 48 inches. So again, you convert your units, then you see, does the height fit the height or the width fit the width? You pick the smaller factor, 4.8, and that's what I multiply my poster height by to get its blown up height. And that's what I did right here to find the height dimension, so 28.8 by 48. So practice this problem. It's a toughie. But you might see it again. Okay, and then the last thing is talking about scale drawings. A scale drawing, you have scale lengths to actual lengths. Okay, so you have scale lengths. It's a scale drawing to the actual length. Each length in the scale, each length in the drawing. So length in the drawing to the actual length. Okay, so if you look here, you have 1 centimeter to 50 kilometers, 1 inch to 100 miles, 1 inch to 10 feet. Typically, you're going to do the scale length compared to the actual length. And again, this is found in most like atlases, or even on like Google Maps. If you look, there's always a scale. All right. So it says the Space Needle in Seattle is 605 feet tall. A classmate wants to make a scale drawing of the Space Needle on an 8.5 inch by 11 inch sheet of paper. He decides to use a scale of 1 inch equals 50 feet. Is this a reasonable scale? Explain. Okay, first thing I do is draw a picture, because I like to draw pictures. The Space Needle, I think, looks something like this. I forget. It comes up like this, but I think it has like that. I think that's the Space Needle. Whatever. That's my Space Needle. And this is 605 feet tall. And we want to fit this on an 8.5 inch by 11 inch sheet of paper. And they're going to use a scale of 1 inch equals 50 feet. And the question is this a reasonable scale drawing? So the idea is we want to take this and put it on a piece of paper. This piece of paper is 8.5 by 11 inches. And I want the scale drawing, I want this needle right here. Right? And the question is it going to fit with a scale of 1 inch to 50 feet? That's the question. Is that going to work? 1 inch equals 50 feet. Again, it's just a ratio, whatever, same thing. So here's what I'm going to do. I'm going to set up my proportion. 1 inch to 50 feet. So the top is going to be the scale drawing, the drawing length. This is going to be, sorry, back here. I'm sorry, I got to come back here. It's not the scale length, it's the drawing length. Okay, it's the drawing length. So fix that. Drawing length. Drawing length to the actual length. So over here, in the drawing, we're thinking 1 inch is going to equal 50 feet in actuality. So I don't know what the scale drawing length is going to be. That's my unknown. And I do know that the actual height is 605 feet. So again, what I'm doing is I'm doing the drawing to the actual. So I'll cross multiply. 50x equals 605, and I'll divide by 50. And this will give me what my actual length, or not my actual, what my drawing length is going to be. 605 divided by 50. I got 12.1. And that's inches. So the question is, does it fit? Does 12.1 inches fit paper? And the answer is no, because it only goes 11 inches. No. So is this a reasonable scale? No. Doesn't fit the paper. Okay. So there you go. So just remember, draw to actual, and you should be fine. Okay, that's it. Thanks for watching. Sorry again. Get your homework done, and we'll see you on Tuesday, last day of school.